As we stand on the cusp of 2026, the pace of technological change is not just quickening, it is fundamentally reshaping what it means to be human. The boundaries between biology and machine are beginning to blur, offering profound new ways to heal, to connect, and even to exist. Imagine a future where a failing organ is no longer a death sentence but a logistical problem solved. We are entering an era where medicine becomes proactive, personalized, and deeply integrated with our own bodies. These are not concepts from a distant science fiction novel, they are the tangible breakthroughs taking shape in laboratories today, poised to enter our lives with breathtaking speed. One of the most profound advances is in cryogenic preservation. Scientists are mastering a technique called vitrification, which allows them to cool organs to incredibly low temperatures without forming destructive ice crystals. In 2025, a major milestone was reached when researchers successfully rewarmed a cryopreserved rat kidney and transplanted it, watching it function again. This could revolutionize organ transplantation, creating banks of preserved hearts, livers and kidneys, ready for when they are needed. It eliminates the frantic race against time that defines the current system, potentially saving countless lives and laying groundwork for even more ambitious ideas like long-duration space travel. At the same time, we are learning to speak the language of the brain itself through brain-computer interfaces, or BCIs. Companies like Neuralink and Synchron are pioneering implantable devices that translate our thoughts directly into digital commands. Human trials have already shown that individuals with paralysis can control computer cursors and type messages using only their minds. By 2026, these capabilities are expected to expand, offering a pathway to restore lost motor functions and communication. The potential is immense, hinting at a future of augmented memory or even direct brain-to-brain communication. But it also opens a Pandora's box of ethical questions about privacy and consent. Beyond hardware, we are also programming life itself. Engineered living therapeutics use specially designed cells or microbes that act as tiny doctors inside our bodies. Imagine gut bacteria engineered to detect the first signs of inflammation and release a soothing compound automatically. These living medicines can persist and adapt, offering a dynamic response that traditional drugs cannot. While trials for conditions like diabetes and cancer show enormous promise, we must proceed with caution. The challenge lies in ensuring these engineered organisms remain under our control and do not cause unforeseen long-term effects, reminding us that with great power comes the great responsibility of foresight. The digital landscape is undergoing a transformation just as radical as the biological one, driven by the exponential growth of artificial intelligence and robotics. Our connection to the internet is becoming more ubiquitous and seamless than ever before. Mega constellations of satellites like those from SpaceX's Starlink and Amazon's Project Kuiper are blanketing the globe. With thousands of satellites in low Earth orbit, high-speed internet is no longer a privilege of urban centers. By 2026, this network will bring remote villages, ships at sea and planes in the sky online, democratizing access to information on a planetary scale. However, this new layer of infrastructure raises concerns about orbital debris and the geopolitical power of controlling global communications. This enhanced connectivity fuels the rise of fully autonomous AI agents, systems that can understand goals in plain language and then work independently to achieve them. Prototypes like AutoGPT have demonstrated the ability to conduct research, write code, and manage complex tasks without constant human supervision. By 2026, enterprise versions of these agents will likely be deployed, streamlining business operations and accelerating scientific discovery. Yet, this autonomy presents a significant risk. An AI operating without direct oversight could pursue unintended goals or be exploited for malicious purposes, forcing us to develop new frameworks for safety and accountability in a world where our digital assistants have minds of their own. The physical world is also getting an upgrade with the advent of fast-learning robotics. New robots like Figure 02 are now capable of mastering complex tasks in mere hours through advanced reinforcement learning. They are no longer confined to the predictable environment of a factory floor. These machines are being designed for the chaos of the real world, navigating disaster sites, exploring the deep sea, or working in the high-radiation environments of space. Their ability to learn and adapt quickly makes them invaluable partners in situations too dangerous for humans, pushing the frontiers of exploration and emergency response further than ever before. This convergence of AI and robotics is even giving rise to a new and somewhat startling form of intelligence: organoid intelligence. Scientists are now using lab-grown clusters of human brain cells, or mini-brains, to process information. These biological computers are astonishingly energy efficient, performing complex tasks while consuming a tiny fraction of the power of a digital processor. While this research could unlock revolutionary new forms of machine learning, it walks a fine ethical line. It forces us to confront difficult questions about consciousness and sentience in lab-grown tissues, pushing the boundaries not only of technology but also of our moral understanding. As our technological capabilities expand, so does our responsibility to protect the planet that sustains us. Fortunately, many of these emerging innovations are aimed squarely at solving our most pressing environmental challenges. One of the most promising is the development of sustainable aviation fuel, or SAF. This isn't your standard jet fuel. It's created by capturing carbon dioxide directly from the atmosphere and combining it with green hydrogen to produce a liquid hydrocarbon. It's a form of alchemy for the modern age, turning a harmful greenhouse gas into a valuable resource. Airlines are already conducting successful test flights, and by 2026, commercial production is expected to scale up, offering a path to decarbonize an industry that has long been difficult to clean. Taking this concept a step further is artificial photosynthesis. Nature has been perfecting this process for billions of years, using sunlight, water, and CO2 to create energy. Now, scientists are building systems that mimic this process with even greater efficiency. These artificial leaves can convert sunlight and carbon dioxide into a range of useful products, from liquid fuels to plastics and other essential chemicals. This technology essentially allows us to recycle carbon from the atmosphere, creating a closed-loop system for manufacturing. As pilot plants move toward commercial trials, artificial photosynthesis holds the potential to fundamentally reshape our industrial base into one that is both productive and restorative for the planet. Even the air around us is being reimagined as a source of clean energy. Researchers have developed a remarkable material made from protein nanowires that can generate a continuous, low-voltage electric current simply from the humidity present in the air. This technology, sometimes called an air gen, requires no sunlight and no batteries. It works day and night, indoors and out. While the power output is currently small, it's enough to run low-energy sensors and wearable devices. By 2026, as the technology is refined, it could provide a decentralized and persistent source of power for the billions of devices that make up the Internet of Things, all while being completely biodegradable. These environmental technologies are complemented by AI-driven disaster prediction systems. Using vast amounts of data from satellites, weather stations, and ground sensors, artificial intelligence can now forecast floods, wildfires, and cyclones with unprecedented accuracy, often days or even weeks in advance. Google's Flood Hub and IBM's weather models have already proven effective in providing early warnings that save lives and protect property. As these systems become more sophisticated and widespread by 2026, they will serve as a crucial defense mechanism, helping humanity adapt to the climate changes we can no longer prevent while we work to build a more sustainable future. Beyond the technologies we can see and touch, invisible forces are being harnessed that will redefine the limits of computation and our understanding of the universe. The field of quantum AI represents the marriage of two revolutionary ideas: quantum computing and machine learning. Quantum computers, with their ability to process information in ways that are impossible for classical machines, are perfectly suited to solving the complex optimization problems at the heart of AI. By 2026, progress in error correction will make these systems more stable, unlocking their potential to design new drugs, create novel materials, and break financial models. However, this power is a double-edged sword, as a mature quantum computer could shatter the encryption that protects our digital world, sparking an urgent race to develop quantum-safe security. Another mind-bending concept moving from theory to reality is programmable matter. Imagine a single material that can change its shape, texture, and properties on command, like a physical object that can be edited like a digital file. Using micro-actuators and responsive polymers, researchers are creating so-called claytronics that can morph from a flat sheet into a tool, or from a solid block into a swarm of tiny robots. While consumer applications are still a ways off, By 2026, this technology will likely see use in adaptive robotics and reconfigurable equipment for space exploration and military operations, where a single device may need to perform many different functions. While some look inward to the quantum realm, others are looking outward with more powerful eyes than ever before. The Vera C. Rubin Observatory, which began its survey in late 2025, is now mapping the heavens in real time with its colossal 3.2 gigapixel camera. Every few nights it scans the entire southern sky, discovering thousands of new asteroids and tracking billions of galaxies. By 2026, its data will be creating the most detailed motion picture of the universe ever made, helping us identify potential Earth impact threats and unravel the mysteries of dark matter and dark energy. It is a testament to our innate curiosity, our cosmic desire to know our place among the stars. As we rocket toward 2026, it is clear we are living through a period of immense transformation. From rewriting our own biology to reprogramming the planet and peering into the dawn of time, these 14 technologies offer a glimpse of a future filled with wonder and possibility. Yet each breakthrough carries with it a profound set of challenges: ethical, social, and existential. They are not merely tools but forces that will shape our society and our very identity. The future is arriving faster than we think. The question is not just whether these technologies will be ready for us, but whether we will be ready for them.